Welcome to Journey of the Universe. Select one of these topics as you like: Universe, Solar System, Sun, Earth, Moon. Click play all to watch full presentation. Click quick play to watch brief of a presentation. Click member details to know about member details. Click exit click to finish presentation. About universe. The universe is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. While the spatial size of the entire universe is still unknown, it is possible to measure the observable universe. Etymology. Etymology is the study of the history of words, their origins, and how their forms and meaning have changed over time. By extensions, the term the etymology means the origin of the particular word. The chronology of the universe describes the history of future of the universe according to Big Bang cosmology. The earliest stage of the universe extents are estimated as taking place 13.8 billion years ago, with an uncertainty of around 21 million years at the 68% confidence level. Physical properties. Of the four fundamental interactions, gravitation is the dominant and astronomical length scale. Gravity's effects are cumulative. By contrast, the effects of positive and negative charges tend to cancel one another, making electromagnetism relativity insignificant on astronomical length scale. The remaining two interactions, the weak and strong nuclear tests, decline very rapidly with distance. Their effects are confined mainly to the subatomic length scale. Size and regions. The size of the universe is somewhat difficult to define. According to the general theory of relativity, some regions of space may never interact with ours even in the lifetime of the universe due to the finite speed of light and the ongoing expansions of space. Age and expansion. Astronomers calculate the age of the universe by assuming that the lambda CDM model accurately describes the evolution of the universe from a very uniform or dense primordial state to its present state and measuring the cosmological parameters which constitute the model. This is about the nature timeline. Space-time. Space-times are the arenas in which all physical events take place. The basic elements of space-times are events. In any given space-time, an event is defined as a unique position at a unique time. A space-time is the union of all events, formally organized into a manifold. Shape. General relativity describes how space-time is curved and bent by mass and energy. The topology or geometry of the universe includes both local geometry in the observable universe and global geometry. Support of life. Universe may be fine-tuned. The fine-tuned universe hypothesis in the propositions that the condition that allow the existence of observable life in the universe can only occur when certain universal fundamental physical contents lie within a very narrow range of beliefs. Composition. The universe is composed almost completely of dark energy, dark matter, and ordinary matter. Dark energy. An explanation for why the expansion of the universe is accelerating remains elusive. It is often attributed to dark energy, an unknown form of energy that is hypothetically permeates space. On the mass energy equivalence basis, the density of dark energy is much less than the density of ordinary matter or dark matter within galaxies. However, in the present dark energy era, it dominates the mass energy of the universe because it is uniform across space. Dark matter. Dark matter is a hypothetical kind of matter that is invisible to the entire electromagnetic spectrum but which accounts for most of the matter in the universe. The existence and properties of dark matter are inferred from its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Ordinary matter. The remaining 4.9% of the mass energy of the universe is ordinary matter, that is, atoms, ions, electrons, and the objects they form. This matter includes stars, which produce nearly all of the light we see from galaxies, as well as interstellar gas in the interstellar and intergalaxies media, planets, and all the objects from everyday life that we can bump into, touch or squeeze. A map of supercluster and voids nearest to Earth. Hadrons. A hadron is a composite particle made of quarks held together by the strong force. Hadrons are categorized into two families: baryons, made of 3 quarks, and mesons, made of 1 quark and 1 antiquark. Leptons. The lepton epoch was the period in the evolution of the early universe in which the leptons dominated the mass of the universe. It started roughly 1 second after the Big Bang. Photons. The photon is the quantum of light than all other forms of electromagnetic radiation. It is the force carrier for the electromagnetic force even when static via virtual photons. This is a standard model of elementary particles. Cosmological models. Model of the universe based on general relativity. General relativity is the geometric theory of gravitation published by Albert Einstein in 1915 and the current description of gravitation in modern physics. It is the basis of current cosmological model of the universe. Multiverse hypothesis. Some speculative theories have proposed that our universe is but one of a set of disconnected universes collectively donated as the multiverse, challenging or enhancing more limited definitions of the universe. Historical conceptions. Historically, there have been many ideas of the cosmos and its origins. Theories of an impersonal universe governed by physical laws were first proposed by the Greeks and Indians. Ancient Chinese philosophy encompassed the notion of the universe, including both all of space and all of time. Mythologies. Many cultures have stories describing the origin of the world and universe. Cultures generally regard these stories as having some truth. There are, however, many differing beliefs in how these stories apply. Almost those believing in a supernatural origin, spranging from a god directly creating the universe as it is now to a god just setting the wheels in motion. Philosophical models. The earliest Greek philosophers noted that appearances can be deceiving and sought to understand the underlying reality behind the appearances. In particular, they noted the ability of matter to change forms, and several philosophers proposed that all the physical materials in the world are different forms of a single primordial material or arch. Astronomical concepts. Astronomical model of the universe were proposed soon after astronomy began with the Babylonian astronomers who viewed the universe as a flat disk floating in the ocean, and this forms the premise for early Greek maps like those of Anaximander and Hectaeus of Miletus. Milky Way and our rotation. Graphic view of our Milky Way galaxy. The Milky Way galaxy is organized into spiral arms of giant stars that illuminate interstellar gas and dust. The Sun is in a figure called the Orion Circle. Overlaid is a graphic of galactic longitude in relation to our Sun. Solar System. Our solar system is an amazing place. Not only it is home to 8 planets, it also holds several dwarf planets, hundreds of moons, and thousands of stars and asteroids. The 8 planets in our solar systems are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These planets orbit the Sun. Mercury. Mercury is the closest planet to the Sun, making it the first planet in the solar system. It is named after the Roman messenger god. In mythology, the god was known for being quick. Mercury is the fastest of all the planets to orbit the Sun because it has the smallest route it has to take. Mercury can occasionally be seen from Earth. Mercury is the second densest planet in the solar system. It is mainly made up of iron. There is no atmosphere on Mercury. Despite its fast trip around the Sun, Mercury's revolution is very slow. One day on Mercury equals about 59 days on Earth. Venus. Venus is the second planet from the Sun. It is named after the Roman goddess of beauty and love. Venus is almost the same size as Earth, but other than size, the two planets are very different. Venus appears to be the brightest planet in the sky due to the reflections of the sun from its clouds and its closeness to the Earth. Venus has an incredibly thick atmosphere. This makes it the hottest of the inner planets. Venus rotates east to west. Venus is covered in volcanoes. Venus does not have any moons. Earth. Earth is the only known planet that has any life forms in the solar system. It is the third planet from the Sun. It is the only planet that is not named after a god. Most of the Earth is covered in water. Earth has thin atmosphere that protects us from dangerous gases and heat in space. Earth is the largest of the inner planets. Air, water and land make up the Earth. Earth's axis is tilted at 23.5 degrees. Mars. Mars is the fourth planet from the Sun, named for the Roman god for war. It is also known as the Red Planet. It is the last of the inner planets. Temperatures on Mars are very similar to temperatures on Earth. It is believed that Mars once has water on its surface. The largest volcano in the solar system is on Mars. It is called Olympus Mons. Mars has two small moons. Jupiter. Jupiter is the first of the outer planets and the fifth planet from the Sun. It is named for the king of the Roman gods. It is the largest of all of the planets. Jupiter is best known for its great red spot, the mass of hurricanes that have been storming for hundreds of years. The spot is larger in size than that of Earth. Jupiter is made up of gases. There is no solid surface on it. Jupiter is so big, Earth could fit inside of it more than 1,000 times. Jupiter has over 50 moons. 4 of these moons are as big as planets. Jupiter has the most active volcanic activity in the solar system. Saturn. Saturn is the sixth planet from the Sun. It is named for the Roman god of agriculture. It is most well known for its highly visible rings. Saturn is the second largest planet in the solar system. Saturn is the most dense planet, being made up mostly of hydrogen and helium. Due to its lightness and speed, Saturn is not round, it is wider in the middle. Saturn's rings are made up mostly of ice. The second largest moon in the solar system is one of Saturn's moons. Uranus. Uranus is the seventh planet from the Sun, the only planet named for a Greek god. Its name comes from the god of the sky. Uranus is unique in that its rotation is horizontal. It is believed that the surface of Uranus will be a huge ocean. It takes Uranus 84 years to orbit the Sun. Uranus rings are perpendicular to it. The clouds on Uranus are amongst the brightest in the solar system. Neptune. Neptune is the eighth and furthest planet from the Sun. It is named for the Roman god of sea. It is the smallest of the outer planets and a gas giant. Neptune is so far from Earth, it is invisible to naked eye. Much like Jupiter, Neptune has a great dark spot containing hurricanes and storms. Winds on Neptune are the strongest winds within the solar system. There are rings on Neptune, but it is believed that they are relatively new. Neptune has 13 moons. Other features of the solar system. There are many other exciting elements in the solar system. Here are a few. Asteroids, coaster myths, dwarf planets. Odds. Asteroids are rocky bodies in the solar system that are too smallest to be considered actual planets. In between Mars and Jupiter lies the asteroid belt containing well over 90,000 asteroids. Comets. Comets are ice and rock that grow tails the closer they get to the Sun. The hotter they get, the longer this tail becomes. The sunlight makes comets glow, which causes them to be visible on Earth. Dwarf planets. Dwarf planets are bodies that orbit the Sun that are not considered large enough to be actual planets. The most famous dwarf planet is Pluto, which was considered an actual planet up until 2006. About Sun. The Sun gives life to Earth, and the Earth would have no life at all without the energy it receives from the Sun. Is the Sun a star? The Sun is the closest star to Earth, our sole source of light and heat in the solar system. The Earth orbits around the Sun. It gives the Earth heat and light. Largest. The Sun is the largest object in the solar system. Approximately 99% of the solar system is located in this celestial object. Sun's energy. Sun's energy is generated by nuclear fusion, hydrogen to helium. Layers of the Sun. Major regions. Interior. Core, radioactive zone, convective zone. Atmosphere, protosphere, chromosphere, corona. Radioactive zone. The radioactive zone of the solar interior is categorized by the process of radiation. Convection zone. The convection zone is a region of the Sun where hot and cooler gases circulate in convection currents. Atmosphere. The atmosphere of the Sun is composed of several layers, mainly the photosphere, the chromosphere and the corona. Photosphere. The photosphere is the visible surface on the Sun that we are most familiar with. Since the Sun is a ball of gas, this is not a solid surface but is actually a layer about 100 kilometers thick. Chromosphere. The next layer is the chromosphere. The chromosphere emits a reddish glow as the superheated hydrogen burns off. Corona. The third layer of the Sun's atmosphere is the corona. It can only be seen during a total solar eclipse as well. It appears as white streamers or plumes of ionized gas that flow outward into space. As the gases cool, they become the solar wind. Solar eclipse. A solar eclipse is a type of eclipse that occurs when the moon passes between the Sun and Earth, and when the moon fully or partially blocks the Sun. This can happen only at new moon when the Sun and the moon are in conjunction as seen from Earth in an alignment referred to as syzygy. In a total eclipse, the disk of the Sun is fully obscured by the moon. In partial and annual eclipse, only part of the Sun is obscured. Solar flares, solar wind and sunspots. Chromosphere emits very little light because it is of low density. Reddish due to 32 lines emission from hydrogen. Solar flares. A solar flare is a violent explosion above the sun's surface. A large amount of energy is released. When this occurs on the sun, the Earth can experience problems with the satellite communications. Very large solar prominence taken from skylight in UV light. Solar flares may last for 10 minutes and will produce more energy than a million hydrogen bombs. This results in the production of a magnetic field that interacts with the Earth's magnetic field. Sunspots. Sunspots appear as dark spots on the surface of the sun. They typically last for several days, although very large ones may live for several weeks. Sunspots are the coolest locations on the surface of the sun. Appears dark only because its gases are a few thousand degrees cooler than surrounding gas, so it radiates less energy. Sunspots and magnetic fields. Typically about 10,000 kilometers across. At any time the sun may have hundreds or none. Dark color because they are cooler than photosphere gas. Each spot can last from a few days to a few months. Galileo observed these spots and believes the sun is rotating differently. Sunspots always seem to occur in pairs, probably due to how thick the magnetic field penetrates the photosphere. Solar wind. The solar wind is the stream of energized charged particles, primarily electrons and protons, flowing outwards from the sun. They cause magnetic storms. Auroras, called the northern lights, occur when layers of our atmosphere are energized by solar winds. Coronal gas has enough heat energy to escape the sun's gravity. The sun is evaporating via this wind. Solar wind travels at 500 kilometers, reaching Earth in 3 days. The sun loses about 1 million tons of matter each second. However, over the sun's lifetime, it has lost only 0.1% of its total mass. Hot coronal gas. Coronal holes are sources of the solar wind. Coronal holes are related to the sun's magnetic field. The active sun. Most of the solar luminosity is continuous photosphere emission, but there is an irregular component. About Earth. Earth is the third planet from the Sun and the only object in the universe known to harbor life. According to the radiometric dating and other sources of evidence, Earth formed over 4.5 billion years ago. Earth's gravity interacts with other objects in space, especially the Sun and the Moon, Earth's only natural satellite. Name and etymology. Originally, Earth was written in lowercase, and from early Middle English, its definite sense as the globe was expressed as the Earth. By early modern English, many nouns were capitalized and the Earth became the Earth, particularly when referenced along with other heavenly bodies. Another convention capitalized Earth when appearing as a name, Earth's atmosphere, but writes it in lowercase when preceded by the atmosphere of the Earth. Chronology. Earth's gravity. The oldest material found in the solar system is dated to 4.5672 plus 0.0006 billion years ago. The bodies in the solar system formed and evolved with the Sun. Geological history. Earth's atmosphere and ocean were formed by volcanic activity and outgassing. Water vapor from these sources condensed into the oceans, augmented by water and ice from asteroids, protoplanets and comets. Earth's magnetic field was established, which helped prevent the atmosphere from being stripped away by the solar wind. A crust formed when the molten outer layer of Earth cooled to form a solid. Over the period of hundreds of millions of years, the supercontinents have assembled and broken apart, roughly 750 million years ago. High latitude regions have since undergone repeated cycles of glaciations and thaw, repeating about every 40,000 to 100,000 years. The last continental glaciation ended 10,000 years ago. Origin of life and evolution. Chemical reaction led to the first self-replicating molecules about 4 billion years ago. A half billion years later, the last common ancestor of all current life arose. The evolution of photosynthesis allowed the sun's energy to be harvested directly by life forms. The earliest direct evidence of life on Earth is contained in 3.45 billion years old Australian rock showing fossils or microorganisms. Several million years ago, an African ape-like animal such as ornithogenisms gained the ability to stand upright. This facilitated tool use and encouraged communication that provided the nutrition and stimulation needed for a large brain, which led to the evolution of humans. This is about the life timeline. Future. Earth's expected long-term future is tied to that of the Sun. Earth's fate is less clear. Physical characteristics. Shape. The shape of Earth is approximately oblate spheroidal. Due to rotation, the Earth is flattened at the poles and bulging around the equator. Thus, the point on the surface farthest from Earth's center of mass in the summit of the equatorial Chimborazo volcano in Ecuador. This is the chemical composition of the crust. Internal structure. The interior structure of the Earth is layered in spherical shells and outer silicate solid crust, a highly viscous asthenosphere and mantle, a liquid outer core that is much less viscous than the mantle, and a solid inner core. Heat. Earth's internal heat budget of the fundamental to the thermal history of the Earth. The flow of heat from Earth's interior to the surface is estimated at 47 terawatts and comes from two main sources in roughly equal amounts. The radiogenic heat produced by the radioactive decay of isotopes in the mantle and crust, and the primordial heat left over from the formation of the Earth. This is the tectonic plates. Surface. The total surface area of Earth is about 5010 million kilometers. Of these, 70.8% or 361.13 million kilometers is below sea level and covered by ocean water. The remaining 29.2% or 148.94 million kilometers not covered by water has terrain that varies greatly from place to place and consists of mountain, deserts, plains, plateaus and other landforms. Tectonic and erosion, volcanic eruptions, clouding, weathering, glaciations, the growth of coral reefs and meteorite impacts are among the processes that constantly reshape the Earth's surface over geological time. Atmosphere. The atmosphere of Earth is the layer of gases, commonly known as air, that surrounds the planet Earth and is retained by Earth's gravity. Weather and climate. Earth's atmosphere has no definite boundaries, slowly becoming thinner and fading into outer space. 3/4 of the atmosphere's mass is contained within the first 11 kilometers of the surface. Upper atmosphere. Above the troposphere, the atmosphere is usually divided into the stratosphere, mesosphere and thermosphere. Each layer has a different lapse rate, defining the rate of change in temperature with height. The exosphere thins out into the magnetosphere, where the geomagnetic fields interact with the solar wind. Gravitational field. The gravity of Earth is the acceleration that is imparted to objects due to the distribution of mass within the Earth. Near the Earth's surface, gravitational acceleration is approximately 9.8 meters. Magnetic field. Earth's magnetic field, also known as the geomagnetic field, is the magnetic field that extends from the Earth's interior out into space, where it meets the solar wind, a stream of charged particles emanating from the Sun. Orbit and rotation. Earth's rotation is the rotation of planet Earth around its own axis. Earth rotates eastward in prograde motion. As viewed from the North Pole star polarized, Earth turns counterclockwise. The South Pole is the other point where Earth's axis of rotation intersects its surface in Antarctica. Earth rotates one in about 24 hours with respect to the Sun. Orbit. Earth's orbit is the trajectory along which Earth travels around the Sun. The average distance between the Earth and the Sun is 149.6 million kilometers and one complete orbit takes 365.256 days, during which time Earth has travelled 950 million kilometers. Earth's orbit has an eccentricity of 0.0167. Habitability. A planet that can sustain life is termed habitable even if life did not originate there. Earth provides liquid water, an environment where complex organic molecules can assemble and interact, and sufficient energy to sustain metabolism. Human geography. Cartography, the study and the practice of map making, and geography, the study of the lands, features, inhabitants and phenomena on Earth, have historically been the disciplines devoted to depicting Earth, surveying, the determination of the location and distance, and to a lesser extent navigation, the determination of position and direction, have developed alongside cartography and geography, providing and suitably quantifying the requisite information. The Moon. The Moon is the easiest celestial object to find in the night sky. The Moon is the natural satellite. The satellite is anything that orbits the Earth. The Moon is a cold, dry orb whose surface is studded with craters and strewn with rocks and dust. The Moon has no atmosphere. Recent lunar missions indicate that there might be some frozen ice at the poles. It is the fifth largest natural satellite in the solar system. The Moon's orbit and movement. The Moon and Earth both orbit around the point between their centers, called the center of mass of the Earth-Moon system. The center of mass then follows an elliptical orbit around the Sun. The Moon revolves around the Earth in about 1 month. It rotates around its own axis in the same amount of time. The same side of the Moon always faces the Earth. It is in a synchronized rotation with the Earth. The Moon's size, weight and gravitational. The Moon's diameter is 2,140 miles. The Earth is 7,100 miles in diameter. That's how far you would have to tunnel to dig to the other side of the Earth. The circumference of the Moon is 6,790 miles. The circumference of the Earth at the equator is 24,901.55 miles. The Moon's mass is about 1/81st of the Earth's mass. The Moon's gravitational force is only 17% of the Earth's gravity. For example, a 100-pound person would weigh only 17 pounds on the Moon. How far away is the Moon? The Moon is about 238,900 from Earth on average. At its closest point, the Moon is 221,460 from the Earth. The Moon's temperature and atmosphere. The temperature on the Moon ranges from daytime height of about Celsius 130 to nighttime lows close to Fahrenheit minus 310. The Moon has no atmosphere. On the Moon, the sky is always appears dark, even on the bright side. Also, since sound waves travel through air, the Moon is silent. There can be no sound transmissions on the Moon. Craters of the Moons. The surface of the Moon is scarred by millions of impact craters caused by asteroids, comets and meteoroids. There is no atmosphere on the Moon to help protect it from bombardment from potential impactors. Also, there is no erosion and little geologic activity to wear away these craters, so they remain unchanged until another new impact changes it. Lunar rocks geologic history. The anorthositic crust exposed in the highlands was formed between 4.0 and 4.3 billion years ago. The mere basalts solidified between 3.1 and 3.8 billion years ago. The moon's surface has undergone very little change over the past 3 billion years. Physical characteristics. Internal structure. The moon is a differentiated body. It has geochemically distinct crust, mantle and core. The moon has a solid iron rich inner core with a radius possibly as small as 240 km and a fluid outer core primarily made of liquid iron with a radius of roughly 300 km. Chemical composition of the lunar surface regolith. Surface geology. The topography of the moon has been measured with laser, altimetry and stereo image analysis. Its most visible topographic feature is the giant far-side south pole, Aitken Basin, some 2,240 km in diameter, the largest crater on the moon and the second largest confirmed impact crater in the solar system. At 13 km deep, its floor is the lowest point on the surface on the moon. Volcanic features. The dark and relatively featureless lunar plains, clearly seen with the naked eye, are called maria. As they were once believed to be filled with water, they are now known to be vast solidified pools of ancient basaltic lava. Although similar to terrestrial basaltics, lunar basalts have more iron and more minerals altered by water.